Alright, welcome back to physics. This is second semester. Hopefully good things will happen this semester. We are going to have to do things a little bit differently since my projector is still out of whack and won't be getting a bulb for a while. It really depends on the district now. They've had the order and haven't fulfilled it. So I've done all I can to push them along. They've just been lazy. Maybe this will end up working out better. If it does, we'll continue doing it. But regardless, I think this is going to be a fine way to learn for the time being. So Unit 7, this is our next unit. It's over circular motion, which when you first hear is not a super exciting thing to talk about, objects moving in a circle, but a lot of students don't actually think about what's happening when something moves in a circle. There actually has to be something that makes it move in a circle, because objects don't exactly move in circles on their own. You know, you don't just start driving down the road and all of a sudden make a turn without something happening, that something being turning the wheel. And explaining that using physics is a little interesting. So what we're going to do is we're going to watch 3 short videos here, and then we're going to come back and kind of explain what was happening in the video, and it's going to give us basically all we need to know about circular motion. Alright, so first off, we're going to watch a video of, it says, a bowling ball that is repeatedly hit so that it travels in a circle. So what I want you to watch in this video is where this hit is occurring and what direction the force from the hammer that this guy is using is pointing in terms of, you know, where it is in the circle. So let's go ahead and watch this. So he looks a little awkward, but that's okay. Hitting the bowling ball so that it moves in a circle, and look at how he's having to direct that force in order to get it to move in a circle. That's a big deal. All right, we'll talk about what direction that was in a second. All right, next. In this video, a ball is going to be spinning around in a frame, and then they're going to take away part of the frame, and the ball's going to move. All right, and I want you guys to think about what direction it's going to move in. All right, spinning in a frame, they take it out. Okay, think about how this ball is going to move once it stops, you know, moving on the frame. All right, we'll talk about what happened there in just a little bit too. This last one, there's a rollerblader who tries to move in a circle just by bending his torso. Obviously that doesn't work. But look at what happens when you give this skater a rope. All right, it's much easier to move in a circle. Think about the bowling ball being hit so that it travels in a circle. It's a similar thing. And then lastly, here's another example. Look at how he's having to push, what directions he's having to push in order to move in a circle. Alright, so like I said, watching those 3 videos will basically give us all we need to know about circular motion. And since this is a video, please feel free to pause this while I'm talking. I'm not going to pause for you in order for you to write this stuff down in your notebooks, which, by the way, you will want to take notes over this. It's just like a normal lecture in class. So go ahead and pause the video if you need to write stuff down. So here's our first rule. All right, rule number 1, a force is required, it should say, to move an object in a circle. Sorry about that. Say an object. Okay, and a couple of things you can think about in these videos that proves this rule. The first one being the skater moving or trying to move in a circle. When he just twisted his body to the left, nothing happened, right? There wasn't a force that made him move in the circle, but as soon as he started to push off with his foot, he started to move in a circle. Same with the bowling ball. If you just roll a bowling ball on the floor, it's going to move in a straight line, right? But if you apply a force to it by hitting it with a hammer or something like that, you can get it to move in a circle, right? So rule number 1, a force is required to move an object in a circle. It will not move in a circle without a force. Rule number 2, this force always points to the center of the circle, right? You saw this in the video when the bowling ball was being forced to move in a circle. Hopefully you saw that every time the guy with the hammer hit the ball, he was hitting it towards the center of the circle. Right? So it didn't matter where the bowling ball was, in its path. If it was here, he hit it downwards so that it moved into the center. If it was here, he hit it to the right so that it was pointing towards the center, and so on. Right? Always towards the center. And we call this force a centripetal force, and this word centripetal actually means center seeking. Right? And it has the word, or the letters C-E-N-T, cent, in it. So you should be thinking center when you hear this word. Always towards the center of a circle. Rule number 3, because a force is needed to move an object in a circle, it must be accelerating, right? If you have a force, you have to have an acceleration. Newton's second law, F equals ma. Right? So the object accelerates when it's moving in a circle. This can get a little tricky. Let's say we're in a car and we're making a circular turn for some reason. Right, so here's my car. I'm moving in this direction initially, and I'm going to turn around in a circle. I can make this circle by moving at a constant speed of 40, let's say, meters per second. Right, if you think about what we learned about accelerations, a constant speed usually tells us that we're not accelerating, right? We define acceleration as a change in speed or a change of velocity. But there is another way that you can accelerate. You can accelerate by changing directions. That's actually a change in velocity as well, because a velocity is a speed and a direction. So even though the speed doesn't change, the direction does. For example, here's where my car is moving initially. If I start making this turn, now I'm moving in this direction. And down here, I'm moving in this direction. Up here, I'm moving in this direction. So you can see at any point in the circle, it changes its direction, which means that it has to be accelerating. Since it's accelerating, there has to be a force that's making it accelerate, and we now know that this force is called a centripetal force because the force always points towards the center. Not the object's motion, but the force that makes it move in a circle. Alright, lastly, rule number 4, when a centripetal force is taken away, the object immediately starts to move in a straight line. You saw this in the video with the frame. Right, the ball was in the frame, it was moving in a circle. When they took out that one portion of the frame, try to draw this as best as I can. Alright, so the ball was moving like this through the circle. When they took out the portion of the frame, let's say here, right, the ball comes around the circle, right? It gets to this point where there's no frame anymore. It will start moving in a perfectly straight line. This is because there's no longer a force to make it move in a circle. And if you remember Newton's 3 laws, his first law, law of inertia, an object wants to keep doing what it was doing. So without a force to make it move in a circle, without anything pointing towards the center, it just starts moving in a straight line, which is what objects want to do when they're moving. They don't want to move in curves or circles, right? They just want to move in a straight line. Alright, this might be weird, but what I'm about to tell you is a force that you should never mention in this class. Alright, I address it because some of you have heard of this force before, centrifugal force. Right? Okay, this force refers to, let's say you're on a roller coaster. Right, and you go through a loop. This is circular motion, by the way. Okay. While you're going through the loop, you will feel that you're being pulled out of the loop at any point on the loop. Okay, this feeling is what people refer to as a centrifugal force. All right, the reason that I'm saying I never want you to use this word is because it doesn't exist. It's not a real force. Right? This is just a feeling that you get. This feeling is coming from inertia. Right? Your body wants to continue moving in a straight line, but some force, a centripetal force, makes it move in a circle. So what you're really feeling is your inertia, that want to move in a straight line. That's what makes you feel like something's pulling you to the outside of a circle. But that never actually really happens. Once again, there is no force that points to the outside of a circle. This is bad. Bad, bad, bad. Right? There's only forces that point towards the inside, which we call centripetal. This is a word that you can use in this class, and it will make me happy. This is a word that you cannot use, right? Bad, bad, bad. And here's the very last thing we need to talk about with circular motion and centripetal forces. It's the centripetal force equation. Very, very simple, right? We represent centripetal force with a big F and a little c. It is equal to the mass of the object times its velocity squared over the radius of the circle that the object is moving in. So just a quick little geometry review. Remember that the radius of a circle looks like this. This is r. Sometimes, now you have to read the problem carefully, sometimes I will give you not r, but the diameter d. So remember, to get the radius, if you're given a diameter, you take the diameter and divide it by 2. That's what's equal to the radius. Alright, that concludes today's lecture. What you need to do now is, on my website, there will be a link to a very short, it's not really a quiz, but a short check your understanding is what I'm going to call it. That basically just asks questions from this video to make sure that you watched it and took notes. So you can use the notes when you answer the questions, but please don't use the video when you answer the questions, because you really should be able to go off your notes and answer all of them. This will be just a normal daily grade. I'll grade it and put it in the grade book. Once you're done with that, I should have already told you or passed out to you the assignment that you can begin working on for the rest of the class, which will in turn become your homework if you don't finish it.